Hey, what's going on, guys? Codec here. In this video we're going to be creating a simple animation using Python and OpenCV, but I don't really want to go for that colored noise and the black kind of circle moving on the screen as they provide in the tutorial. So the video effect that was supposed to be coding in this tutorial would look like this. So it's very simple, nothing special, but we're interested in actually how to make it using Python and OpenCV. So if you're interested, without further ado, let's actually start writing some code. So first we need to import some packages. I need to say import CV2, then from CV2 import video writer, and then from CV2 import video writer for CC. These two are needed to write the frames into the video stream, and also we need to import numpy as np to actually formulate a frame we're supposed to be writing our pixels to. Next thing to consider, we need to open image file. So I can simply say image equals to, so remember that we have the image in the current working directory, this one, image1.jpg. So cv2.imageRead and this image1.jpg and cv2 imageRead unchanged. Okay, now just for debugging purposes, I want to show the image in a window. I'll get rid of this code later on. I'll comment this out, but for now I can say cv2.image show. Let's give a window some name. Let's call it image, and the image we want to show. Then to escape from this GUI kind of loop, we need to say cv2 wait key and wait for whatever key pressed. And finally I want to destroy all windows. So now let's open the terminal in the current working directory, and by typing Python 3 fade in .py, we should see the output image. Okay, perfect. Well, I'm not sure whether it's okay to call this effect fade in or not. So if you know how to properly call this sort of a video effect that we're coding in this video, please let me know in the commentaries, because I don't really know how to properly call it. Okay, so the next thing to consider, we need to define the video codec. Let's call it like this. So I'm using this for CC, which equals to video writer for CC, and I'm gonna be using the MP42, and let's say define video stream. So the video would be equal to the video writer, and the video name, let's call it video.avi. Then we need to specify our codec, so for CC, then the frame rate, so I'll use 24 frames per second, and finally the width and the height of a given frame. However, we didn't yet define this width and height, so let me just comment this out for quite a bit of time. And now we want to extract width and height from the original image, because I want to make a video of exactly the size of the I want the video to be the size of the original image. So if we just say print and image.shape, In this case, we'll see the width and height of a current given image. So I hope it's clear. So we need the first value and the second value to initialize the width and height. So here we can simply say width equals to image dot shape and the second element, and here the first element, and here I have the height. Okay, so now I can uncomment this kind of part. Okay, and as far as we have our video stream here, so to finish the process of video recording, we need to release our video. So we can simply say video.release. Okay, and here is the main logic. So the main logic is to loop over all the pixels within the original image and using some sort of an algorithm just to print those to a new frame. But let's first define the frame. So let's init empty frame first, and let's not release the video for a while. So frame, this would be just numpy zeros. So I want to initialize an array of zeros, and this would be our height, weight, height, width. Okay, we have three colors, RGB, red, green, blue, and we want to use the size of npu integer 8, which is the size of every given cell. Okay, so we can actually print our frame. Display, we can display our frame. It should be just a black one. Okay, nice. So from now on, we no longer need to display anything here, so I can comment this out. We can release the video, and here, so now we need to loop over all the pixels within the original image. So first we need to loop over, let's call it pixel rows in the original image, and here we can simply say for, let's call it y, for y in range. I'm using range here because later on I'm going to be randomizing this stuff. So range and length of our image, and here we want to loop over pixels within a given row. So we're going to like row by row like this. Okay, so for x in range, the length of image indexed by y, and here we want, here we would be like draw, we want to draw pixel, on frame. Okay, and for now we just print the pixel on its own. So let's say pixel, and this would be image indexed by y and x, like this. Okay, yeah, this should be the case. It takes time because there are really lots of pixels. I'm not going to be waiting until it gets to the very end, but here is the idea that we have the values for red, green, and blue, values of a current of every current given pixel. Okay, so now let's record so-called black screen for our video, and then we'll go to actual drawing of the pixels. So here we want to write video frame, let's say. Well, if we just write every frame, so let's say video dot write and frame, it kind of takes a bit too long, and yeah, let's just pass here for a while, and here let's just say write in frame, and let's create a frame count here just to give an idea how many frames we'll write in each eventually. Frame count equals to 0, save. So frame count plus equals 1, and here just want to use this frame. And let's have a look. How long does it take? Yeah, not that much. Okay, so much faster. And I already should create this blank video with only black screen on. So it takes 13 seconds. It's a bit too long, so we'll reduce this later on. But for now, I'll leave it as is. Just to give an idea how the speed of this video effect that we're coding can be actually adjusted. So now we have a blank black screen video lasting for 13 seconds. Okay, so now the most important thing in this entire program, so we need to actually draw a pixel on a given frame. So I can simply say cv.circle, and we want to be writing this. We want to write this to the frame, to this array of numpy array of zeros, to this one. Okay, so we want to write our x and y values. So this is the center of the circle, because we're using circle here. Then the radius, I specify radius equals to 1. Then the pixel value, so here we will have the RGB values for our pixel, and the thickness -1, because I want to make it look like a pixel. So here I need to use, well, I could have actually, so it should be, I just need to use this. Let me just make this, and you'll then see what I mean. So if I just print image x, y, x, and let's say 0. So here is the value for red, here is the value for green, okay, and the last one is the value for blue. Okay, so we also need to turn this into the integer, because by default it's not integer. I just already know that. And eventually we need to say like 1, 2. Okay, let's make this just a bit more readable. I can also provide I think this might be on the cards, like this. I could provide what current given element stands for. So here we have frame to right pixel 2. Here we have center coordinates of a circle. Here we have radius, circle radius. Here pixel red value. Here we have a pixel green value, and here we have a pixel blue value. If we had a black and white, then instead of this tuple we would have used a single integer to represent, or if this was a grayscale as well, so we would use a single integer to represent either the grayscale or just the binary value, like 255, which means true, stands for white, and 0 like stands for black. Okay, and here we have the thickness, but it's set to -1, so it looks like a pixel eventually. Okay, so I hope this is clear, and if I did everything correctly, it now should already be capable of rendering in printer style, rendering the image in printer style and produce a video out of this. And it seems to be exactly the case. So you see, like now it's already a video right in pixels in this sort of a kind of what I call a printer mode. Okay, but 13 seconds is a bit too long for this effect. So now let's reduce the time of how long does it take. So in order to do this, we can simply say if and y moduled with, let's say, 10 equals to 0, and in this case we write a frame. So we would be skipping some frames now, and the video should be shorter from now on. Okay, so now it only takes 1 second. Okay, it's a bit too fast. Okay, so maybe we could go for let's make it just, it was 13, so to make it 5 seconds, I think moduled with 2 would be just fine. So let's quickly check this out. Sorry. Yeah, I think this bit is quite pretty nice. So we have 6 seconds per effect. Well, it might be arguable, but you can play around with the value right over in here. So the greater this value is, the shorter the video would be. Okay, so right, am I right? Yeah, the greater value results the shorter video. So 10 video module with 10, it would be like 1 second video. Okay, so the next step to consider, we don't want this printer-like style, but we want to randomize the order of the lines being drawn on a frame. Okay, so here we want to init random row indexes. So let's call it random rows equals to, and I'm using this range, but I want to list this range. So in this case I can use random shuffle methods. So I also want to import random. Okay, and here now I can shuffle rows indexes in random order. Okay, so I can simply say random dot shuffle and random rows. It does affect the original array, so after the original list. So after this shuffle is done, this random rows actually starts being random. They are not random before this line is occurring. So if you want to get rid of this randomness, you can just comment out this line. So that's clear. And now we need to loop over the random rows. And if I did everything properly, it should do the trick. And currently the video should appear in this kind of like, okay, so this is the mode it appears in. Again, like every next time it would be slightly different. And yeah, I just reduced the size of image, and that's the reason why the quality is not really that great. So well, let's actually see. Let's actually see how it would look like. How it would look like in a full-blown mode, kind of like. Yeah, I'm sorry for videos a little bit laggy. Yeah. Okay. Okay. Okay guys, I just found an image in a slightly better resolution, so it takes a bit longer to process. However, it should result in a better quality video. So I just need to change the file name here. I'm sorry. So this would be GPG instead, and still here I think something like this should be fine. So let's quickly try to run this again. Okay, so it takes a bit longer because the video is bigger. I'm sorry for lags in my web camera. Yeah, that's because it's quite pretty processing power consuming task. Okay, now we're done. And let's have a look at the video. So it should be much better now. Okay, yeah, now it's much better. Okay, so you see like the quality now is much better. So we just go in for this in full screen. Here we go. But probably the last thing to consider, it just ends up too quickly. So the very last thing to consider, we want to write just some frames at the very end with a just, let's call it like keep image for keep image frame for some time. And let's just make a simple loop. Let's say for x, let's say for I in range of, so how many frames we want to create here. So let's create like 500 frames more, and we can just write the frame write complete frame like this. And if I did everything properly, it should now result in writing 500 more frames were just still image, like without anything. So I hope that's gonna be working. Okay, now I didn't really type this. So how right? Oh, probably it's gonna be longer compared to. Okay, I'm sorry guys. So let's say let's give it 200 and let's keep the frame count as well here. So just to be aware of where we currently are. Okay. Okay, so it now should be okay. Okay, and you see now it's not disappearing. We still can enjoy Jennifer Aniston appearing on our screens. Well, okay guys, so this is it from my side. I hope you've enjoyed this tutorial. Thanks for watching. Until the next time, and take care.